Frankly, I had given up hope to ever be a famous writer whose work would be comparable to what Charles Darwin did for evolution and Einstein did for gravity. By now, I have completed 6 revolutionary books in terms of the way they displace conventional beliefs about the universe, motivation, overthinking, leadership, and now learning. The predicament that I was in is that I had the theory and the logical soundness along with the anecdotal and phenomenological basis, but I did not have the empirical basis. I knew that. I also knew that until I could present my discoveries in the realm of psychology, spirituality, cognition in a scientific manner, I would not even make a dent in the world. Nonetheless, I kept on writing because I couldn't stop myself. I secretly wished that I would meet at least one PhD aspirant who would take up my theories and put them through a scientific process so that the world could take notice. You'd ask why I wouldn't do the PhD myself? Well, I'm not built for academics, and that's my weakness. In terms of my own forebrain learning approach, I'm dominated by the wisdom brain quadrant, whereas to do your PhD, you've got to be strongly dominated by the diagrammatic opposite skill-based quadrant. And then as I was researching for this chapter on statistics, I not only learned this subject using artificial intelligence instead of learning it in an MPhil class. But I realized that when people said that AI was the fourth industrial revolution, they really meant it. The first industrial revolution occurred with the first general purpose technology, which was the steam engine in the 1770s. It made factory labor mobile, meaning not tied to water power to run the factories. Then it created the modern railway system, fundamentally changing geography and commerce. After that, nothing was the same ever again. In the 1980s, the second industrial revolution took place because of the general purpose technology that electricity was. It enabled the distribution of energy everywhere. It enabled factories to be built anywhere. It automated tasks like lighting and machine operation and powered consumer electronics, which are the bedrock of the 20th century. Although not considered as an industrial revolution, the third JPT was the automobile, which began in the early 1900s. I don't need to say much about it because that's such a obvious benefit to humanity. Third industrial revolution, also known as the digital revolution, was heralded with the information technology and the computer from the 1970s onwards. This JPT automated information processing, storage, and retrieval. It mechanized tedious skill-based office work and created global data networks and enabled the internet. This led to the fifth general purpose technology of full-scale internet in the 1990s onwards. It created entirely new markets, e-commerce, democratized information using the search engines, and fundamentally changed how people socialize, shop, and learn. And then Unknown to most of us, in the 2010s, the sixth general purpose technology of artificial intelligence began the fourth industrial revolution. Basic function was to automate cognitive tasks, identifying patterns, generating contents, and making complex predictions. I never thought that AI was a revolution for real, let alone for me, until I used it for this book. Well, yes, it helped me learn without a professor and joining any university, but that can't be really classified as a revolution of the industrial scale, right? But it gets interesting when I try to do my own research on how to apply what I have just learned about statistics. To keep it short, one thing led to another, and within a few days, I realized that the Industrial Revolution, that is the fourth one, had occurred for me also. I felt like I was in a dream where suddenly I realized that gravity didn't pull me down and I could fly. We've all had this kind of dream, but this is the nearest description of how I felt at that moment. As I had told you earlier on, my frustration and my hopelessness, despite all my phenomenological research, was that I did not have the resources to convert them into empirical studies based on facts and established scientific practices. But then my collaboration with Gemini AI took me into Alice's Wonderland. I can't find a better word for that. It's not only not being affected by gravity and flying, it's finding unthinkable possibilities. I knew that the biggest problem for my empirical research was statistics. I did not know how to use SPSS and Python. I even didn't know inferential statistics. I saw box plot diagrams in the thesis of my friends, but I had no clue what it meant or that I could ever understand. I used to read books of famous researchers who used to brag that their findings were of very high significance, but it did not mean important. Instead, it meant something not random, but it just felt so alien. I was just happy to understand the data visualization that they provided. Secretly, I was jealous of them because they had the knowledge and the technology and the manpower to run those empirical tests to prove their points. I would have loved to learn statistics, but it was too steep a curve for me. And if I engaged in that climbing journey, I would have to forsake my research on the unified theories, everything, something that I could not sacrifice, even if it meant that I would die in obscurity because of a lack of empirical proof for my findings. And then when I opened the door to Alice's Wonderland, I realized that the sixth general purpose technology and the fourth industrial revolution was real. All I needed was to know what I wanted to investigate. Then, using AI, I could make a hypothesis. I could even ask the research function of Gemini to provide me any existing research on the topic that I was investigating. Since I knew exactly what I wanted, but just didn't have the skills, I just used AI even to prepare my study design. I was always good in making questionnaires, so that's never a problem yet. AI provided me with good feedback. Data collection, data entry was never a problem, especially after the internet, since whoever uses physical forms now in the age of Google Form. Then I could put all the data into an AI and tell it to explore it. That is a descriptive statistics part. It would even provide me the report with the data visualization, for which it would provide me the Python code. Gemini even coached me how to download which Python software. So I chose Anaconda. I asked who should I approach to learn Python. Should I go to institute, or would it be better if I learned from AI itself? Gemini, having learned my pattern already, told me that I could give it the high-level requirement and it would provide the Python code and the HTML codes and the React codes as needed. Then I could learn from them. That would be much more efficient than learning from zero, that is the syntax and the various command languages. That was a great idea. So now I could do hypothesis testing for not only a single independent variable, but multiple independent variables. There was no limit to how many tests I could run. There was no limit for how many hypotheses I could test. And everything came in the format that I gave it to provide the answers in. Not only that, I could demand a certain standard for reports, interpretations, and data visualization. Through dozens of iterations, I would get the desired code, and most of the diagrams that you are seeing in this chapter are born from this process. So it provided me the report, and all I had to do was to interpret the results. That also, if I was confused, I could pose my understanding and ask if I was right or wrong, and it would correct me accordingly. Can you imagine the revolution that has occurred? If this is not Alice in the Wonderland, then what is it? Now I feel so reassured about my own work. I know that my unified theories are not only revolutionary, but they are also going to be empirically tested. Not by some PhDs, but by the writer or myself. The learning curve was so short. What I thought would take me decades to learn, I learned in a month. Of course, I have no skills in actually how to find out the p-value or the Pearson's coefficient, and certainly not how to make a neural network in a predictive engine. All that doesn't matter. Do you need to know how your car operates? No, you just need how to drive it. This is the stage that I found myself in terms of statistics using AI. Let me take you to the two diagrams below. They describe my experience in a more systematic way. The first diagram talks about inferential statistics, and the second one about applied statistics. Essentially, they are telling the same story. In the first diagram, there are the 10 steps of statistics that we have discussed earlier, and that I have briefly outlined in this section itself as I was describing the metamorphosis that I underwent as a writer. The second column contains the relation with the forebrain learning model that we have used in this book to that particular step. The next four quadrants represent four eras of statistics. First one is the manual calculation era, which is pre-1970s. That is a world before the computers. Then the second era represents the SPSS and the Excel era. This is the outcome of the third industrial revolution, courtesy of information technology, started in the 1980s up to the 2000s. The third era is the Python and R era. Although Python was invented in the 1990s, it became popular and effective as a statistical tool only in the mid 2000s. And then we have era 4, which I'm definitely part of, where statistics performed using AI or LLM as an assistant. Still so futuristic though. I might even be the pioneer of era 4 of statistics. At least in the individual level. So what this table is telling you is that of the 100% effort, time, energy that a researcher can devote for statistics in the various areas, his efforts are divided as shown in the table. The data visualization for that table is the pie diagrams below. Consistent to my own story, what you will notice in each of the steps is that across the eras, amount of effort required on the part of the researcher decreases in steps from 2 to 9. This is because all that work has been automated. But it significantly decreases in era 4 because coding in Python, R, or any language doesn't require to know the code now in the age of AI. So as you can see in the diagram, in the era 4, where you too can belong, the biggest effort can be put in observation and interpretation of the results. That's what matters the most. The rest can not only be automated, but with high language programming, it means that you don't need to know code, you just need to speak in natural language and AI will convert it into the required codes to produce the various statistical outputs and the data visualization that's required. The diagram next to it represents a similar shift across the various eras in which brain quadrant is more required. At the beginning, the skill brain quadrant, which asked the how and had to focus on the details, calculation, and data entry, occupied more than 50% of the time. Then, knowledge brain quadrant, which answered the question what we are investigating, thus focusing on the logic, hypothesis, and study design, took up 22% of our efforts. Then we had to spend 15% in the information brain quadrant, which was about language, review, and report writing. It had to be presented, and it took time to write and to present and make diagrams. Finally, only 10% would have been left to explore the why of that research and the synthesis it could do across other fields and its implications, applications, future possibilities, limitations, and so on. So this wisdom brain quadrant answered the why, focusing on strategy, observation, and interpretation. Myself, I am dominated by the wisdom brain, as I've told you earlier. So I couldn't imagine doing statistics in that era. Not even in the Excel era or even the Python era. But look at what happens in the fourth era. I can contribute 65% in the wisdom brain quadrant and only 11% in the skill brain quadrant, just enough to know how to talk to the AI with my natural English language. Can you imagine the jump that has occurred? I repeat, if this is not Alice in the Wonderland, what is it? The second diagram tells the same story, but this time for applied statistics or advanced modeling and data analytics. You can refer to the diagram itself. We discussed the 5 steps of applied statistics. You can see a pattern. You can cross-check it with the diagram or pie charts. As you can see, the biggest chunk of the effort, the earlier errors, was in the collection and the data processing. That was significantly reduced with AI because it can do the data cleaning and mining much faster. And in the step 3 of the build model, you'll see that the effort is increasing from era 1 to 2 to 3, and then decreasing in era 4 of AI. This is because over the period of 2000s onwards, lots of new problems were investigated, which were of very high stake and high chaos. These require data scientists, and they work very hard to build the models. But again, AI will help them in the future because they don't need to many things manually that they did before, like cataloging and making the formulas and teaching them. That would be reliably done by AIs. Still, in problems of high stake that we discussed earlier, the data scientists will still have to do it manually, and that's why the 20% saved time can be used in defining the problem even better, like we did in the observation part earlier on. And you can see that the biggest chunk of the effort is now spent in deploy and monitor, actually about testing and using the predictive models more and more. Inferential statistics, using AI to find out the various statistical outputs like the chi-square, t-test, z-value, was quite straightforward. But in applied statistics, it's a bit more complicated. Here we have to build a model in order to get an answer. For that, you will need to refer to the AI system architectural diagram that I have shown below. I actually did it myself, so it's not just hypothetical, it's real stuff that I did. You will see the example of it later on. I use the same predictive model architecture to make an app to predict traffic. More on that later on. So how this works is that we're to start with the database. It's where you put the X features and the Y values for the engine to come up with the formulas. Nothing more than a glorified Excel sheet. The professional setting, it's called the SQL. It basically stores log data, past outcomes, and historical factors, and keeps the data integrity perfect. Once you have this database ready, then you make the backend server, which is the second most important thing in this algorithm architecture. It's written in Python or Node or JavaScript. It's used to make an API gateway, authentication, security. Before era 4, all the mathematics and statistics would be done in the backend itself locally using Python itself. But now the API of the backend, as you can see, links it to the model engine of Gemini API or others. But since I use Gemini, I just mentioned this particular Google product. So this is the core feature that enables anybody, any layman like me, to make a predictive engine. Ethical purpose, you should not rely solely on this architecture for high-stake problems, but for low-stake problems, it's okay. Again, this Gemini API is most flexible for not only low chaos problems, but high chaos problems. You can deal with not just a dozen, but hundreds of variables if you ask it to. So now that you have the core architecture, you need to have it working, so you need a front end, and that is done using React and Vue. Again, I provided the natural language prompts to Gemini, and it provided me the code for everything from React to Python. I built the front end myself, which you'll see later on. And as a user, you put in the request. Before that, a training agent would have to put in the data into the database, the offline mode. Then the fourth step of evaluating the errors should have been to take place, and then the deployment. In conclusion, what I want to say is that the world has really changed. It had beginning change since the first industrial revolution. By the fourth industrial revolution of AI, more and more people will find themselves in Alice in Wonderland, like I have. As you have seen in this section, there is no limit anymore, at least in terms of research. It requires statistics, as demonstrated by the 55% effort that we can now spend on observation. Anyone with a great idea can use LLMs to perform the 10 steps of statistics and build predictive models that was unthinkable of. As a writer, I am at peace finally now, knowing that the legacy that I'm going to leave behind will be based on statistics or empirical research. Just a month ago, I didn't know about it. Now that I know, I spent 55% of my research time, as per the diagram above, in wondering what findings I want to investigate. I always wanted to do scientific research in what I've been calling spiritual science. There is physical sciences and there are social sciences. It could be spiritual science, but because writers and practitioners in this field don't know statistics and have no interest in learning it in the backwaters. But with my newfound superpowers of omnidata sense, I can now spend my time in choosing what hypothesis on the spiritual science I want to make and I want to test and tell the world. Can you imagine the possibilities? On a parting note, I would like to say that even a child could use the architecture that I just made, the predictive engines, whether he'll pass in the exam or not, or whether he'll get scolded for not doing his homework or not the next day. It's that simple. Child could even get serious about degrading relationship of his parents and try to do an inferential statistical research on it. The hypothesis could be that whenever his father comes home late, the parents quarrel. That's his observation at least. But he's not sure. So, using ERA 4 AI, he could go through the 10 steps, and then the research could tell him that there is correlation between his father coming late and the parents quarreling is high enough, and the p-value is low enough that can reject the null hypothesis that quarrel of parents occur randomly, irrespective of the father coming home late or not. So basically now the kid knows for sure a certain degree of significance that later his father comes, longer the quarrel is. However, the test could have gone the other way around, and it could have failed to reject the null hypothesis that we just mentioned. Then this child would need to conduct another relationship study. Maybe he would study if there is a relationship between his parents' quarrel and the call that his father gets from the creditors, or visit by the in-laws, or a certain time of the week. Then using AI, this child would run all the various hypotheses. Then he would come to a conclusion. I might say it is highly improbable, but it's a potential that the fourth era offers. There is no more any limit what can be investigated, because the bars have been lowered so low that even a kid can cross it. So I am ever more hopeful now as I'm towards the end of this chapter on statistics. I welcome the fourth industrial revolution of AI with full gusto. What about you? Is that enough for you to love statistics and to see its real value like I have?